Simulation is a quantitative method of analyzing uncertainty. Simulation is a quantitative technique of analyzing what? Uncertainty. And with simulation here, there are some basic requirements that you must be provided for. For you to be able to simulate a question, so these are the requirements that you must have in a question. Number one is a probability distribution. You must be given the probability what? Distribution of each variable you want to simulate. Of each variable. That is the first thing you must have. So if you want to simulate sales, they must give you probability distribution of what? Sales. If you want to simulate the quantity, they must give you what? The quantity. Number two, you must also determine your cumulative probabilities. You must determine your cumulative probabilities of each variable. The cumulative probabilities of each variable. Once you have the probability, you can now determine your cumulative probability by adding. The third item you want to have is you're going to get your random number ranges. Your random number who? Ranges. Show you that. Then number 5 is you must also have your who? Random numbers. Random numbers here basically are numbers assigned that show equal chance. They are numbers assigned that show equal chance of occurrence. So random numbers. Once you have determined your random numbers, or once you've been given your random numbers, this case in an exam situation, they will always provide the random numbers. Number 5 is you set up your simulation worksheet. Your simulation worksheet. You must set up your simulation worksheet where you're going to simulate your information. Those are the requirements that are required for us to be able to carry out what? Simulation. So I want us to go to a question. Let's go to December of 2022. December 2022. Question 2A. Question 2A. December of 2022. Question 2A. They are saying, Lengo Limited is considering marketing a new product. The fixed cost of this product will amount to 5 million. There are 3 uncertain factors, namely selling price, variable cost, and annual sales volume. Selling price is for 400, for 50, and 500 with a probability of 0.3, 0.5, and 0.2 respectively. Variable cost is 200, 250, and 300 with a probability of 0.1, 0.6, and 0.3. Your annual sales volume in units is 40,000, 50,000, and 60,000 with a probability of 0.4, 0.5, and 0.1. Additional information. Assume that the 3 factors are statistically independent. The company uses cost, volume, profit analysis to make decisions. The following random numbers are provided. You have your selling price with a random number of 8, 0, 6, 1, 3, 5, 1, 3, 9, and 1. The variable cost, the random numbers are 0, 4, 3, 4, 6, 7, 2, 8, 5, and 9. So let me repeat the variable cost random numbers: 0, 4, 3, 4, 6, 7, 2, 8, 5, and 9. The sales volumes had the following random numbers: 6, 3, 9, 4, 0, 9, 7, 6, 8, and 5. Required. Using CVP analysis criteria, simulate the problem and determine the average what? Profits. Simulate the problem and determine the average what? Profits. Number 1. For us to do this question, we must confirm what we've been given. Have we been given the probability distribution of each variable? Yes, we have been given. So, come here and get the selling price. We have the selling price. You have the shillings, the selling price in shillings, 400, 450, and 500. Your probability, which I denote as P0, is 0.3, 0.5, and 0.2. Let's get our cumulative probability. Let's determine our cumulative probability. This is 0.3. 0.3 plus 0.5 is 0.8, and that is 1.0. The next variable that we have probability is variable cost. So remember, all these uncertain items, you must be given probability. You must be given what? Probability. Your variable cost is 200 with a probability of 0.1, 250 with a probability of 0.6, 300 with a probability of 0.3, 0.3. So that now your cumulative probability is 0.1, 0.7, and that is 1.0. That is for who? For variable costs. The third item that we have our probability distribution is your sales volumes in units. In units. The units are 40,000, 50,000, and what? 60,000. Your probabilities 0.4, 0.5, and 0.1. We need to determine our cumulative probabilities. 0.4, 0.9, and that is 1.0. 1.0. Right. So what we have effectively done is we have the probability distribution. Then using the probability of each variable, we have determined our cumulative probabilities. Our cumulative probabilities. That is in order. All right. Once we have done that, we then need to determine our random number what? Ranges. Our random number ranges. So let me come back here. Computation of random number ranges. So let's again start with selling price. 400, 450, 500. Your probabilities 0.3, 0.5, 0.2. Your cumulative probabilities 0.3, 0.8, and 1.0. Then your random number ranges, I'm just going to write them there. Your random number ranges there. Now your random number ranges will be between 0 and 2. So we normally say when you're determining random number ranges, the ranges should be inclusive. They should be inclusive, such that if you start between 0.2, then the next observation should be between 3 and 7. Then the next one is between 8 and 9. 8 and 9. Okay? That is the selling price. Let me go to what? Variable cost. Some of these items I am repeating, which is also in what? Shillings, probability, cumulative probability, and random number what? Ranges. $200, $250, and $300. Probability is 0.1, 0.6, 0.3, 0.1, 0.7, and 1.0. The random number ranges now will be between 0 and 0. Why? Because you've said it must be exclusive. It must be inclusive. It must be inclusive. Then 1 to 6, 7 to 9 must be inclusive. That is your variable cost. Let's now finalize determining the random number for sales volume. Cumulative probabilities: 40,000, 50,000, and 60,000, 0.4, 0.5, 0.1, 0.9, and 1.0. Then we must determine our random number what? Ranges. So this is 0 to 3, 4 to 8, 9 to just 9. Summer 9 or 9 to 9, no problem. 9 to 9 there. So remember, what guides us when you're getting the random number ranges? Number one is the decimal point. So if we had two decimal points here, for example 0.30, I would have written my random number ranges in tens, not ones. Here they are in ones, because the decimal place is in one place. So if they are more than what? One decimal place, if it is more than one decimal place, I will also have the random number more than once. More than once. So let me adjust that. Right. That is wonderful. Let's now prepare our simulation worksheet. Our simulation worksheet. Okay. We have already been provided the random numbers, so that we have. So we want now to prepare our simulation worksheet. When you're preparing this simulation worksheet of CVP, you're going to prepare it according to what is being asked in the question. And here they are telling us required: simulate the problem and determine the average what? Profits. How do we get your profits? You say it is P minus V by the units minus your who? Fixed costs, minus your fixed cost. So this is how your simulation worksheet should look like here. Okay. So the first item should be your selling price. But because selling price, you've been given random numbers and the probabilities, so because it was uncertain, we will come here and write the random numbers and your selling price P. There. The variable cost, we did also being provided the variable cost, their probabilities and random numbers. So again, we introduce random numbers for variable cost and who? And the variable cost there. Then your random number for the units you want to do what? To sell, for the units Q. For your units. Then we know or we can first determine our contribution margin. Let's first determine our contribution margin CM, which is given by P minus V. So this is not fully a requirement, but let's just determine it. If you're able to just compute directly, well and good, but let me show you that so that we simplify our work and we look more organized. Okay, so that is P minus V, contribution margin. Let's get the random numbers for your units, for your units, then we get our total contribution and your fixed costs, and then lastly your profit. Lastly your profit. We can even try squeezing this, left so much spacing, so we can readjust this. I'm just rewriting this so that it is better off for you, or it is better off for the students to see. And fixed cost, and then your profit, and then your profit. All right, that is how a simulation worksheet of CVP should look like. The first random number of selling price is 8, and with the selling price of 8, or rather with a random number of 8, your selling price is between 8 and 9. The random number, you normally read it according to the random numbers. So you go to your selling price, and where you have a random number of 8 and 9 is at a selling price of how much? 500. So here you're going to write what? 500. Then variable costs random number is 0. Your variable cost with the random number, when your random numbers are 0, your variable cost is 200. Then your contribution margin will be 300. Why? 500 minus 200. The next random number of sales volume is 6. And with the sales volume of 6, of random number 6, your units should be 50,000. Then to determine our total contribution, you're going to take your contribution margin by your units. So I believe that is 150 or 15. 1, 2, 3, 4, 5. Your fixed cost was 5 million. Fixed cost was 5 million. Then you get your what? Profit. Then you get your what? Profit. Is that a profit of 10 million? That is a profit of what? 10 million, All right. The next random number is 0. So allow me to just write these, all of them together. 0, 4, and 3. With the price of 400. Why? Because with the selling price of 450 actually, because your random number is between 3 and 7, So 450. Let me see. Yeah. Your random number is 0. So your selling price is 400. Don't get this confused here. 400. With a random number of 4, your variable cost is 250. So your contribution margin is 150. With a random number of 3, you're selling how many units? 40,000. Okay, we'll come back to the contribution. Then 6, 3, 9, 1, 4, 4, just highlighting the random numbers now, 3, 6, 0, 5 7 9 1 2 7 3 8 6 9 5 8 1 9 5. Now write the random number of 6. Your selling price is 450. 1 is 400. 3 is 450. 5 is 450. 1 is 400. 3 is 450. 9 is 500. 1 is 400. Variable cost of 3 is 250. 4 250. 6 250. 7 300. 250. 8 is 300. 250. 300. So remember, what is guiding us is our ranges. The quantity, 9 is 60,000. 4 is 50,000. 0 must be 40,000. 60,000. 7 is 50,000. 6 is 50,000. 50,000. And lastly 50,000. This is 200. 150. 200. 150. 150. 150. 250. 100. Then what do we do now? We get our total contribution. 150 by 40 million. 40,000. That is 6 million. Your fixed cost is 5 million. 250. 200. 200 by 60,000. This is 12 million. That is still 5 million. So that should be 7 million. 7.5 million. 5 million. 2.5 million. This is 8 million. 5 million. If fixed cost is not changing. 3 million. 9 million. 5 million. 4 million. 7.5. 5 million. 2.5. 7.5 million. 5 million. 2.5. So remember, your total contribution is contribution margin by the units. Please don't forget. That is why 300 by 50 is that. What have you? 250 by 50,000 must be 12.5. And that is 5 million. 7.5. This is 5 million. Then we get our profits. Let's get our profits. We simply add these profits. Plus 2.5 plus 2.5 plus 7.5. Is that 40 million? So therefore your average profit. Remember, in the question they are asking for average what? Profit. Going to take 40 million divide by the number of times you've simulated. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 4 million is your average profit. 4 million is your average profit. And that's how we simulate what? CVP. That is how we simulate CVP. All right, I hope that has been properly understood, such that if it comes to question, you will be able to do what? To handle it. So the remaining items is sensitivity, statistical analysis, probability tree diagram, and continuous or normal distribution. Continuous or normal distribution. All right. Now, we're going to cover these next items during the next what? Session. During the next session. So from me, I wish you the very best and see you in the next session. Goodbye.